Okay, what we want to do in this particular lesson is to graph polar equations. Now, we've been graphing points. So if you have a point in r theta, where r is a function of theta, and you know the angle theta, generally we've been using radians, but you can think in terms of degrees, then you find out how far at that angle are you away from the origin. And that's what r is. Now what we're going to do is look at certain equations and see if we can graph these equations, which will be connecting basically a bunch of points, r theta points. So the one we want to graph here is r is equal to 2 minus 2 sine of theta. And what I've done is I've created sort of two tables. It would be one, but I didn't have enough room to make it just one, so I split it up into two. And we'll start at, say, 0 radians for theta, and we'll just go every pi over 4 amount of radians until we get to 2 pi radians. So basically we're going every 45 degrees, if you want to think of it that way. So for each of these thetas, we'll plug it into the r equals 2 minus 2 sine of theta and see how far we are away from the origin. So I'll start with the first one here. If theta is 0, then we're going to get 2 minus 2 times the sine of 0. Well, the sine of 0 is 0. So we get 2 minus 0, which is 2. If we use pi over 4, we're going to get 2 minus 2 times the sine of pi over 4 will be the square root of 2 over 2. So what this will become will actually be 2 minus the square root of 2, which is about 0.6. So I'll try to squeeze in a 0.6 there. For the next one, if we have pi over 2 and plug that in, we'll get 2, r will be 2 minus 2 times the sine of pi over 2, which is 1. And you can verify some of these on your calculator. So 2 minus 2 times 1 is 0. If we use 3 pi over 4, we'll get 2 minus 2 times the sine of 3 pi over 4. The sine of 3 pi over 4 will be the square root of 2 over 2 again. And so this will be 2 minus the square root of 2, which we already said was about 0.6. Okay. And then to complete the first half of this table, if we use pi, which is 180 degrees, to find out how far we're away from the origin, we'll get 2 minus 2 times the sine of pi is 0. So we end up with 2 minus 0, or 2. Okay, so we're halfway done with our table. If I use 5 pi over 4, r will be 2 minus 2 times the sine of 5 pi over 4, which is negative square root of 2 over 2. So in this case, we're going to get 2 plus the square root of 2, which is about 3.4. If we use 3 pi over 2, r will be 2 excuse me, minus 2 times the sine of 3 pi over 2. The sine of 3 pi over 2 will be negative 1. So we'll get 2 minus 2 times negative 1, which is the same as 2 plus 2, or 4. If we use 7 pi over 4 for theta, we'll get 2 minus 2 times the sine of 7 pi over 4, which is negative square root of 2 over 2, which means we'll get 2 plus the square root of 2, which is about 3.4. And finally, to finish this thing off, 2 pi, which is the whole way around the circle, basically, we'll get 2 minus 2 times the sine of 2 pi is 0. And so we end up with just 2. Alright, so basically we have now 1, 2, 3, 4, 5, 6, 7, 8, 9 points that we can graph. And so we'll go ahead and on the next slide I'll go ahead and graph each of these. I'm going to change color here a little bit. There we go. Alright, so I'm going to take the first point that I see in my table, which is when theta is 0 radians, r will be 2. Let's plot that point. So at 0 radians, which is on the x-axis, I'll be out at 2. So here's my first point right there. My second point will be at pi over 4 for theta, that's 45 degrees, and I'll be 0.6 away from the origin. So at 45 degrees, I'll be 0.6. So that's not quite 1. So each of these circles increases by 1, so I'm going to be right about there, approximately. All right, so let me go back. At pi over 2, which is 90 degrees, r will be 0, which means I'm 0 distance from the origin. So I'm kind of rotating 90 degrees, but I'm going to be right at the origin because r is 0. Okay. And then let's pick up the next one. At 3 pi over 4, which would be 135 degrees, r is 0.6. So I'll rotate like 135 degrees, and 0.6 puts me right about here. Not quite out from the origin by 1. Let's go pick up the next point. Pi radians. So pi radians would be 180 degrees, and I'm 2 away from the origin there. So at 180 degrees, which would put me on the negative x-axis, I go out 2. So I'm on the circle that has a radius of 2. Alright, so at this point, let me stop here. And I'm going to connect all the points from the first one that I had. I'll connect to the next point, then to the next point, then to the next point, then to the next point. So I'm just kind of following the increasing theta and connecting all the points. This is what I have so far. So it looks like kind of a couple little humps there. So let me go back. Now we'll pick up 5 pi over 4, which would be 225 degrees. And we calculated r would be about 3.4. So let me graph that one. So at 225 degrees, or 5 pi over 4 radians, which would put us in the third quadrant, I'm out about 3.4. So right about here with that dot. At 3 pi over 2, or 270 degrees, I'll be on the bottom portion of the y-axis. We will be 4 away from the origin. So I'll be down to here on the circle that's 4 away from the origin. So let me connect these last 2 points. So I'll curl down to here, pick up that point, down to here. And now I have 2 more points to look at. So go back to the table. I'm going to pick up 7 pi over 4 for theta. And we figured out that its radius, or r, or its distance from the origin, is 3.4. So that angle of 7 pi over 4 is like 315 degrees. I'll be in the fourth quadrant, and I'll be out to about 3.4, which puts me right about here. So let me connect that point. And finally, the last one. At 2 pi radians, r is 2. Well, 2 pi radians is 360 degrees, which is equivalent to 0 degrees. So we actually return right back to here. And if you look at the picture we drew here, it kind of looks like a heart. It's actually called a cardioid. And now you have an idea how you might graph some of these polar equations.